This is a Core 3 past paper question using substitution to solve an integration problem. First of all, I will do part A. The integral between the natural log of 2 and 0 of e to the power 1 minus 2x with respect to x. We have to show that it is equal to 3/8 of e. Because it's an exponential function, when I integrate e to the x, I have to divide by the differential of the power. Because it's a linear power, I don't have any great problems with that. So I can divide by -2. So I use square brackets because I have integrated. I don't need a constant of integration because there are limits. Once I've done that, I can substitute in the natural log of 2 and then 0 into my terms, and I need to evaluate it with my okay, so clearly I can tidy that up. The key thing is the power for the first term. I'm going to split it into two parts because using laws of indices there, that is easy to do. So I get e to the power 1 multiplied by e to the power -2 log 2. And then I'm going to subtract from that the other term. Two negatives make a positive, and e to the power 1 I can just write more neatly as e. Tidying up the other side. The key thing there is to write this as e to the power of a natural log. I'm raising 2 to the power -2, which is a quarter. E to the power of a natural log is that value of a quarter. And that's going to give me -1/8 of e plus a half of e is 3/8 of e, which is what I was asked to show. Moving on to the second part of the question. The part B asks me to do integral between pi over 4 and 0 of sec x to the power 4 multiplied by the root of tan x with respect to x. Kindly, they give me the substitution. They tell me that u is equal to tan x. The first thing I do is differentiate u, because I'm going to need that when I change dx into du. So du dx equals sec squared x. You should know that. It is in the formula booklet, but hopefully you don't have to spend time looking that up. So I need to change the limits of integration. When x equals pi over 4, I will get u equals tan pi over 4, which is 1. And when x equals 0, u is going to equal tan 0, which is 0. So I now get my integral is equal to integral between 1 and 0 of sec x to the power 4 multiplied by root u. That's I'm replacing tan x with u, and I go from dx, and that gets swapped with dx is equal to dx du multiplied by du. I've worked out du dx, which is sec squared x, so I need to write du divided by sec squared x. Clearly I can simplify this integral now. I can divide through by sec squared x. That still leaves me one term that's in terms of x. I need everything in terms of u. So what I'm going to use is a trig identity to rewrite that. Tan squared x plus 1 is identical to sec squared x. Therefore, I can replace that tan squared x I can write in terms of u. That is u squared plus 1. And now I can continue with my integration in terms of u. I need to expand the brackets, so I've got discrete terms. I'm going to write them as numerical powers. And now I can perform the integration, increase the power by 1, divide by the new power, and do the same thing with the second term. Now I need to substitute in my values. When I put in 0, that disappears, so I can tidy that up. And I get my answer.